So we have this really cool thing called the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x over h. That's the rule. Everybody got the rule? So if you want to find the derivative of a function, we worked with the derivative at a point, which means we use the letter a. That's notation for at a point. Right now, x refers to all values of the domain. Okay? So what I do is this tells me that I do the limit as h goes to 0. And what do I first plug in for x? X plus h. And so you get x plus h over x plus h minus 3.
Yes. But you write itty bitty, you're fine.
Does anybody have a question on that?
I feel stupid. I'm already lost.
So see how it says f of x plus h?
Yeah.
I take the x plus h and I dump it in for x there and there.
Oh.
Then I have a subtraction sign, and now I just subtract f of x, which is just the function, right?
Yeah.
So I subtract x over x minus 3.
Ow.
And that all sits over what?
H.
It all sits over h. Okay, so this example teaches us to work with a complex fraction. Okay, complex fraction. So you see that you have here two fractions in the numerator. So how will I combine those together? I will create common denominators. So you multiply this side by x minus 3 over x minus 3. On the other side, you multiply by Is there any question how I got to where I am now? Okay. Notice algebra intensive. Agreed? Yep. Limit as h goes to 0. Now we're going to try to write out the numerator. I take x minus 3 times the x plus h. If I FOIL that out, what are we going to get?
X squared minus 6h plus 9.
Not
Never mind,
quite.
there's x and an h.
You're lying.
Hold on.
X squared?
Minus
Minus
6hx.
No sixes. No sixes.
I don't know.
Minus
Minus 3x
Oh, I thought there was a 3 in the other
Plus
one too.
XH.
plus xh
X squared plus
minus 3h.
x h minus 3x.
Am I okay with that?
3h. Okay.
Okay, and then do I distribute x or negative x?
Negative x.
I get negative x squared
Minus HX.
minus xh
Plus 3x.
plus 3x.
I have a question and it might not be a very smart question.
It's okay. We need to start to embrace the not so smart questions because that means 3 other people are thinking the same thing.
Probably not. So, you know how when we were taught to use like X's and H's and all that, H would go before X because it's like that in the alphabet? So
No,
like
x
she,
would come before h.
She's saying that H is like comes first. In the
I
alphabet,
understand.
So why does it not go?
I understand.
because
Because X is
someone
more
just
important.
said HX instead of XH and you corrected them.
Does it even matter?
It doesn't matter. It
Okay.
doesn't. I usually just write the xh. Typically, when we're writing the polynomials, what happens in our notation in this situation is, and you're right, there's not a strong rule mathematically for it, but you always put your coefficient first. You then put your variable that is being part of the dependent variable. That would go next, and then anything after that.
Okay.
So that's just generally how this is written out. And I'm just being conditioned by the textbooks I've read over the years. That's it.
Okay.
So, but excellent question. Thank you. And then on the bottom you have x minus 3 times what?
X plus H minus
X plus h minus 3. Okay, and that all sits over
H.
h over 1. I'm going to write. All right. So we've kind of gotten to the point, we've understood that if it doesn't have an h, then it should cancel. So what cancels up here? X squareds are gone.
Oh, never mind.
Negative 3x and positive 3x are gone.
And the XH.
Yeah, it looks like even some things that have h's are gone, right? The positive xh and the negative xh, those are gone. And so we have a negative 3h, right? Follow here, because I want to save you time. Here's a nice little trick you can do at this point. I'm dividing by what? By h, right? So I should multiply by the reciprocal. So watch, if you multiply by the reciprocal, see how all that does is it brings an h into the denominator? Yeah. So I now have the limit as h goes to 0 of, I have negative 3h over x minus 3 times x plus h minus 3. And notice that h is in the denominator. If we can pause for a second and just go back to all the things we talked about in this class so far and connect, what would happen if we plugged in 0 for h? What would you get? 0 over 0. We've seen that before, have we not? And so again, this is a problem calculating 0 over 0. Yes?
If you multiplied by 1 over h, how come the h's didn't cancel out? So why is it just 3h on the top?
So I'm going to do that right now. Yep, so Hattie's just one step ahead of us. We're going to now reduce this h with that h, and we get the limit as h goes to 0 of negative 3 over x minus 3 times x plus h minus 3. So in order to finish off this derivative, what is the last thing I have to do? Plug in 0 for h. And when you plug in 0 for h, what do you know about what do you see about this denominator piece? They're the same, and so we get negative 3 over x minus 3 quantity squared. That's the derivative.
On the test, like on the homework, we had like x to the 5th. Is there gonna be ones like that on the test? Okay.
Now there will be.
Allie did x to the 5th, and that's an excellent problem to go through because as you see that one, that's going to help you make a heck of a lot more sense about what we do on Monday. So I loved seeing you do that. Sir?
So if you graphed like negative 3 over x minus 3 squared, that'd be like the graphs we were making for the derivatives, right?
Yes.
That would be- okay.
Yep. So let's go to Aiden's point here for a second. As he looks at this graph here, x over x minus 3, I want you guys to know what that graph looks like. And what it looks like is this. It looks like this. Tell me about the slope of that graph the entire time. It is always negative. Everybody agree? The slope is always negative. And so if you were then going to graph negative 3 over x minus 3 quantity squared, that graph looks like this. So if the derivative is always negative, that means it should always sit below the x-axis. So the blue one is this graph right here. It's always below the x-axis because the slope of the red one is always negative. And if you graphed it, it would confirm for you. So your matching exercise you did, you could try to confirm those things by putting them on your calculator. Yeah. Excellent question. Good. Last one.
I have another question.
Yeah.
When we're writing it out on the homework, the second one to the bottom, so you have the h in there. Could I just get rid of the h?
Absolutely. Absolutely.
Okay.
Yep.
Wait, so what you derive from it is the slope?
Yep. That thing will produce the slope. So that's the beautiful thing about it. Before, we always had to plug in a value. Now, what you have is this, Hattie. It says that f prime of x is equal to negative 3 over x minus 3 quantity squared, right? So let's say you want to know the derivative at x equals 4. Well, then just plug in 4. And notice how you get negative 3. That's the slope.
So that was like the a.
Yeah, if you want to know, well, what's the slope at x is equal to 0? Then you just plug in 0. You now have a rule that will give you the slope all the time. So you don't have to do multiple ones. You can just do one and be done. Super helpful. Extremely useful. I have a short story about this piece I want to share with you, but I can't share it with you while I'm recording. So I'll share it with you right after we're done, and it'll connect well for you. You'll appreciate it, promise. Okay, last one. I want to do the derivative. F prime of x is equal to the limit as h goes to 0 of what?
2 over the root of x plus h.
Good. 2 over the root of x plus h minus
2 over root of x.
all over
H.
h. Sweet. Oh boy, we've got two things going on here, don't we? We have both a complex fraction and we have a radical, correct? Now, I'm not going to lie, there's been years I haven't done this problem simply because I was like, I don't know if the kids are too smart to understand it. You guys are smart enough to understand it. Yay! Pat yourselves on the back. Way to go. Yay! The truth is I just decided I need to stop cutting material out because it hinders people. So we want to approach all the difficult problems, okay? Can I show you a trick and then you can let me know what you'd like to do? If you want to pull that 2 out, you can. Like, let's say, like, you could just treat this as 1 over the root of x and do that, and then in the end, multiply the final answer by 2. You could do that with a constant. What would you like to do? Do you want to keep the 2, or do you want to multiply the final result by 2? Which would you rather do? Okay, we'll keep the 2. If you like that trick, feel free to use it. I definitely used it when I did it, but as you get more comfortable, you might say, oh yeah, I'll just do it with a 1 and then I'll multiply the final answer by 2. So constants work that way. You could just kind of pull them out and push them back in, okay? All right, so complex fraction and radicals. Ah. Deal with the complex fraction first. Multiply top and bottom by root of x plus h over root of x plus h, and as Hannah said, this side by the root of x over the root of x. And I get the limit as h goes to 0 of 2 roots of x minus 2 roots of x plus h over root of x times root of x plus h. Good, I like it. All over h over 1. Okay. You see how we've now made one fraction? I'm sorry, a complex fraction where you have one fraction numerator, one fraction the denominator. So this is the trick I want to show you before. Notice how you can multiply by the reciprocal, and what do you end up with when you multiply by the reciprocal? H in the denominator. Everybody see that? So I could just go ahead and simplify this to throw an h in the denominator. Boom. Now I see that I have gotten rid of that complex fraction piece. Complex fraction piece is done. But I have this nasty, nasty radical. And you notice when you're trying to get rid of these radicals, instead of doing math, you have to do Spanish. So we're going to multiply by the conjugate. Let's go. We've got 2 roots of x, then what? Plus 2 roots of x plus h. Over 2 roots of x plus 2 roots of x plus h. It would seem to me that the denominator is going to look rather disgusting. Does everybody agree?
Yeah.
Denominator, super ugly. Let's just all admit, right? So don't let that deter you. Let's focus on that numerator. And here we are. We have the limit as h goes to 0 of, what do you get when you FOIL that guy out? 4x, good. The middles disappear, right? What's going to be next? Yeah, so minus 4x minus 4h. All over, oh boy, h roots of x plus h times 2 roots of x plus 2 roots of x plus h. Ick. Man, I've been doing this for 25 years and I still think it's ugly when I see it.
You don't have to just foil it out or anything?
That bottom?
Distribute it? Or
No, just
put them together?
we'll see the denominators in a little bit here, okay? We'll see the denominators in a little bit, okay? Right now, I want you to focus on what happens.
X's can X's.
4x's are gone. We anticipate that because you've learned that everything that doesn't have an h will disappear. And then what else do you notice?
The H's can, the two.
That the h's are gone, aren't they? So you have the limit as h goes to 0 of, in the top we have -4, and in the bottom we have, it's just smaller by the h, but we have that whole rest, root of x plus h, parentheses, 2 roots of x plus 2 roots of x plus h. Okay. All right, so as we tie this off, you guys are almost there. You've done a great job. What is the last thing we have to do to tidy this up? Yeah, 0 needs to go in for h. And this is the really important moment with this problem that you notice. When the h goes to 0 there, and the h goes to 0 there, notice how it just becomes the root of x? And so you have a -4 over, what's the root of x times the root of x? X. What's 2 roots of x plus 2 roots of x? 4 roots of x.
Wait, 4 roots of X.
So here I have 2 roots of x plus 2 roots of x. That makes 4 roots of x. Uh-oh, what do you see now? Radical in the denominator, it's okay because it has a variable, so we're going to let it be. We don't have to worry about that, but 4 divided by 4 is 1. And so you get just -1 over, and you can write this as x roots of x, or you can write as -1 over x to the 3/2 power. Can somebody explain to me how I got x to the 3/2 power?
X to the first plus X to the 1/2.
So x to the first power times x to the 1/2 power. If you take 1 plus 1/2, you do get the 3/2. I tend to like the fractions a lot of times like that. But some people write it like that. Either way is just fine. Either way is just fine.